I'm Dr. Mustafa. I'm associate professor in School of Hospitality, Tourism and Events, Taylor's University. I'm a PLS lover, so I like a lot PLS because of the benefit of PLS for different models and for analysis. So I think PLS is a great help for researcher to actually perform their analysis with the different level of complexity. I have published more than 80 papers in different journals, and several of them are in top tier journal. In most of my papers, I applied the PLSSEM with different software. I use SmartPLS, PLS, Adanco, and the other PLS software. So in different papers based on actually advantage and disadvantage of these software packages, and see which one is more suitable for my study. So I apply in my papers, and using different software, I publish papers. So you can
SmartPLS,
so you can actually see my paper using different software. But in this session, I will focus on SmartPLS, not other software. Maybe in the future, near future, I organize another session and another course using PLS, especially PLS, and we will discuss PLS advantages and some features of PLS and how perform analysis with the PLS. But in this actually course, I will focus on SmartPLS. Okay, during this course, actually, for this fourth session, I will try to cover some basic feature of PLS-SEM, some basic definition of PLS-SEM, and also assessment of measurement model and structural model, and actually create a framework and model in SmartPLS and assess the measurement and structural model using SmartPLS. I will try to cover these aspects in first session, today's session. In second session, I plan to focus more on higher order construct. So see how we can create, what's the meaning of higher order construct, how we can create higher order construct in SmartPLS software and in PLS in general and in software, and how we can assess higher order construct if our framework or model include the higher order construct or latent variable. In third session, I try to focus on mediator, and in the last session, fourth session, I will focus on moderator and multi-group analysis. So I will try to cover a basic features and basic stuffs in assessment of measurement model, structural model, higher order, mediator, and moderator, and try to get familiar with these features and performing these features in SmartPLS software. Okay. For structural equation modeling, just very quick, I try to cover some basic definition and basic understanding and description about SEM, PLS, and the difference between PLS-SEM and the CBSEM. SEM is the second generational analysis technique, is different with first generation, and in SEM actually we can work with the latent variables, and no need to work only with observed variable. You know, in first generation we can work with the observed variable, And if we have latent variable, we need to transfer we need to transfer latent variable to observed variable. Means if we measure one variable with some items, we need to calculate score of these items and get the score of latent variable. So create new variable and work with this new variable, latent variable score in our analysis, for example, in multiple regression, in first generation of analysis. But in second generation, you know, we can work with the latent variable. And actually, we can assess measurement model and the reliability and validity of latent variable. So this is the first reason that we prefer, especially in social science disciplines, we prefer to work with the SEM because of this capability to work with the latent variable. Another one is SEM can work with the framework and model with different level of complexity. But in first generation, we have many limitations. For example, in multiple regression, just we can have one DB or relationship between one layer. So if we want to analyze a complex model, so we need to split or we need to perform analysis in a few times to run. But SEM can perform analysis and assess a structural model in any level of complexity and simultaneously. So this is another advantage of using SEM, that we most of the time we go to apply SEM compared to first generation of analysis, especially in social science discipline, because in social science disciplines, we work with most of the time with latent variable, we work with the attitude, we work with satisfaction, loyalty, we work with some variable that we don't measure directly, and actually we measure indirectly by some observed variable, right? Okay. Another thing that I just want to explain before going to we have some basic features and some differences with the first generation. For example, in second generation, we don't use independent variable and dependent variable. And instead of these concepts, we use outer model and inner model. Actually, sorry, we use exogenous variable and endogenous variable. Actually, exogenous variable is something similar to independent variable and refer to variables in our framework that no other variable pointed to this variable. So we call this variable exogenous. And we have endogenous variable. Endogenous variable is something similar to dependent variable, but not exactly same. But and the endogenous variable is a variable that other variables in the framework, other latent variable and construct, pointed to this variable. Like here, attitude, we have ease of use, usefulness, and the ease of use and usefulness are exogenous. But attitude is endogenous construct or latent variable. Another concept that we work a lot in SEM and use this concept is inner model and outer model. Outer model or measurement model refer to relationship between observed item and construct. So when we talk about relationship between items and construct, actually we are discussing, we are working on outer model or measurement model. But when we refer to relationship between variables, between latent variables, here we have a structural model or inner model. So inner model or structural model refer to relationship between variables, but outer model and measurement model refer to relationship between observed items and latent variable. So we can say measurement model or outer model refer to when we talk about measurement model and outer model, actually we refer to discussing and working and analyzing within a construct. So we see inside a construct what happened. Inside the construct, how observed variable connected to latent variable. But when we discuss a structural model and inner model, we refer to relationship between variables. So we say in the literature, we need two types of theories, measurement theory and structural theory. Measurement theory refer to the way that we measure our latent variable and construct. But structural theory refer to a theory that support relationship between construct and hypothesis. So we need to discuss these two types of theory in literature to support measurement model, measurement of each construct, and to support a structural model. Okay. So this is a few concepts that we use in SEM and okay. For measurement model, one very important concept is formative and reflective measurement models. Formative and reflective measurement model, this is part of measurement theory. That is how we actually measure our construct. So we need to understand the nature of our latent variable. And then based on the nature of our latent variable, we can identify this construct is formative or reflective, how we operationalize our construct or latent variable. There are variable can be categorized under measurement model, can be categorized under reflective and formative, but actually under formative, we have two types of formative, composite and causal formative. Just to explain very briefly, it's very important to understand because of two main reasons. One is for reflective, formative, and composite construct, we need to apply different criteria to assess measurement. So if our construct is formative, so we cannot apply same criteria to assess measurement model. If our construct is reflective, so we need to apply some specific criteria for assessment of measurement model. But if it's formative, causal formative, or composite formative, we need to apply other criteria. So we need to understand. We need to understand the nature of construct. This is one main reason. Another reason, if our construct is formative, we need to add something when we develop our questionnaire. We need to add some more observed item, more items in our questionnaire. Then we need these items for external validity or convergent validity of formative construct. So we need to identify. So it's very important to realize and identify our construct are reflective and formative because of these two reasons. Okay, what's the difference between formative and reflective? Actually, formative construct, this is a mathematical formula for reflective construct. In the reflective construct, the direction of arrow is from latent variable to observed variable. And there is one specific error in observed item, observed variable level. So the equation for representing item for reflective construct is lambda 1 multiply latent variable plus error term. So we have x1 is lambda 1 x if this one is x, x1, x2, and x3, lambda 1x and error 1, right? So, and the x2 is lambda 2x error 2, and the x3 is lambda 3x error 3. So the error term is in observed level, and lambda 1 called outer loading or loading here. In reflective construct, all observed variable reflect the meaning of construct. So each observed variable can reflect whole meaning of construct, right? But in formative construct, the formula is different, and the mathematical equation is totally different. If see this mathematical equation of latent variable construct in formative construct here, you can see weight instead of loading. So W1x1 plus W2x2 plus W3x3 together create or establish latent variable, form latent variable. So the concept is totally different with reflective construct. Here you can see error term is in latent variable or construct level. So is not in observed variable level. So here we have W1x1, W2x2, W3x3 plus error term. So these all together create latent variable. So here we have weight, not loading like reflective construct. And actually here error term in reflective construct represents a missing observed item to establish latent variable. And we need to calculate these missing items. And convergent validity and external validity of formative construct actually refer to calculating these missing items. So, for example, for this one, here we have one example of satisfaction, but we measure satisfaction based on two different set of items. Here we have in right side, we have formative items. So we measure satisfaction based on the service is good service quality of based on the evaluation of service, based on the evaluation of personnel, the personnel are friendly and the room is well equipped. So here you can see we measure satisfaction from three different perspectives. Three different perspectives. Also, we can add more variable here. For example, satisfaction about environment, satisfaction about accessibility. But each variable measure part of satisfaction. But what about left side? In left side, we have, I feel well in this hotel. I'm always happy to stay in this hotel, and I recommend this hotel to my friend. So if I answer, for example, for first one, I answer, yes, I strongly agree. My answer to second question will be similar to this one. I will be agree or strongly agree. I won't be strongly disagree, right? So the items for reflective construct are high correlated. But what about here? What about formative? It's possible to be satisfied with the service of this hotel, but not satisfied about personnel or room equipment. So this one depends on satisfaction about each aspect. So when we include formative items measure different aspects of latent variable, and all together measure satisfaction. For reflective, each item can reflect the meaning of satisfaction, but is not correct for formative concept. But for formative, it's possible to miss some item like environment of hotel, like accessibility, some other variable. And these variable, this missing variable actually represent and increase error part. So this error part in formative construct should not be more than 50% of meaning of construct that is represented by, more than 50% should be represented by available items, and this missing part should be less than 50% of variance of latent variable. In PLS, actually, sometimes we refer to reflective construct, we refer to mode A and mode B, but actually mode A and mode B is different with nature of construct. When we say reflective and formative, we refer to nature of construct, as I explained before. But mode A and mode B are two algorithms that we apply to calculate score of latent variable based on nature of latent variable. If nature of latent variable is reflective, we apply mode A. If nature of latent variable is formative, we apply mode B to calculate score of latent variable. I'm not going to go through these slides because there are many studies that there are misconceptualization of formative and reflective, and the paper published in top tier journals. So you should be very careful for this one. This is actually the composite construct, and this equation represent composite construct. The difference between composite construct and formative construct is in composite construct, we don't have error term. Actually, composite construct is something that in the literature say there is not exist in real world, and we design composite construct. So this is the difference between composite and formative. If something already exists in real world, and we measure based on formative items, so this will be causal formative. But if we design something based on different aspects, right? Like here. So we don't have any error term, right? Because we consider all items that we wish to consider to measure this composite construct. So this is the difference between composite and causal formative and composite formative. For example, marital status can be a composite construct. Actually, we can transfer to a composite construct. Or here, watching TV, frequency of watching TV. So actually, we measure based on watching TV during week, watching TV on Saturday and Sunday. So these three totally can represent frequency of watching TV on by children, right? So this is an example of a composite construct. Here, there are some work that Hensler, 2017, tried to explain difference between especially composite and formative construct, and identify composite construct as an artifact because we actually design it's not something that exists in real world. Also, we have an editorial. Actually, we publish a special issue in Journal of Hospitality and Tourism Technology in 2018. And in editorial of this special issue, we try to identify in a simple word, we try to identify the difference between PLS-SEM and CBSEM, and also different types of construct, reflective, formative, and composite, and explain what's the difference between these type of construct and how we need to measure and how we can measure, and actually what's the criteria to assess these different types of construct, reflective construct, formative construct, and composite construct. So you can refer to our paper for understanding of this concept. we try to explain in a very simple language. Here also I provided some differences between PLS-SEM and CB-SEM. In the recent year, you know, there are some criticism for PLS-SEM, but actually there are some misunderstanding. Actually, the Carl Droskog and Hermann Wold that developed at the beginning CB-SEM and then together PLS-SEM, consider these two methods as a complementary method. So these two methods are used for different purposes. So it's not something that we can use instead of each other. So each method is suitable for some situation and based on objective of our research. So there are some literature to understand the differences between these two approaches. Also in this editorial, we try to highlight some differences between covariance-based SEM that also in the literature is known as a common factor-based approach, and variance-based SEM or PLS-SEM that is known as a composite-based SEM. So you can see, actually the objective of these two are two completely different. CB-SEM is minimizing the difference between covariance matrix from data and from model. So we compare these two. So goodness of fit is very important in covariance-based SEM because goodness of fit represents the difference between covariance matrix of, from data and covariance matrix from model. But the objective of PLS-SEM is maximizing the explained variance of endogenous construct. So it's not talking about minimizing the difference between covariance matrix. So goodness of fit in most of situations for application of PLS-SEM is not necessary and somehow useful. So we discuss in this editorial also, you can find a lot of literature to discuss difference between PLS-SEM and covariance-based SEM. PLS-SEM, we apply, actually PLS-SEM is a prediction-oriented approach and is suitable when the objective of our study is theory development, not theory testing. But CB-SEM is suitable for theory testing because actually in CB-SEM, we need to provide goodness of fit and compare covariance matrix from data and from model. So we need to see model fit based on this data fit in this model, and so what's the actually the evaluation of fit in this, right? So is suitable for theory testing. PLS-SEM is can work with the more complex model. When we have the combination of reflective and formative, PLS-SEM is more preferred approach compared to CB-SEM. Actually, it's not possible when we have a combination of formative and reflective to apply CB-SEM. And addition to these two main differences and purposes of PLS-SEM for reasons for application of PLS-SEM, also PLS-SEM can work with non-normal data because apply bootstrapping method and resampling methods. Can work with the smaller sample size, but not based on this 10 times rule. This 10 times rule is not no more acceptable in the literature. But there are some method to calculate minimum sample size. There is a paper by Koch and Hadayat that they discuss two methods for to calculate minimum sample size for PLS. So this is the difference between these two and some reason to apply PLS-SEM compared to covariance-based. So there are different software for CB-SEM and software for PLS-SEM. Some of these software are more popular and well-known, like SmartPLS is the most popular software to perform and apply to use for PLSSEM, and also VAR PLS is another software. Addonco is other software, and some other software that you can use to perform PLS. But in this session and in this course, actually, we will work and focus on SmartPLS. Okay, so I tried very quickly cover some basic stuffs and the features for PLS-SEM before starting assessment of measurement model and structural model. Any questions so far? Maybe we can go for 1 or 2 questions before going to assessment of the measurement model and the structural model and start to use software.
I think, Prof, it's clear, and we have to need to go through again for these all to understand in details. So yeah. I think we can move to practical session now.
You can later go through a slide, and if you have any question, we can discuss.
Prof, can I ask you a question?
Yes.
Okay. The question relates to composite variables. As you told that composite variables or constructs are the ones that we are trying to, when we have the, so it means when we are, in the process, or we have developed a scale for a particular construct, there are some methodological papers when you criticize the scales available for a particular construct, and then we come up at the end of the paper, we come up with the changes in that scale, or once we have developed a new scale or for a construct. So can we, in that situation, we call it a composite construct?
If actually we're changing a scale, it depends on the scale and the nature of the scale. If the nature of a scale is something that, for example, we develop a scale with higher order construct and levels, right? So we have a few dimensions to measure, for example, perceived value, right? We have a few dimensions, but we know these dimensions actually perfectly can represent the meaning of the perceived value. We have a functional dimension, a social dimension, emotional dimension. So we have all dimensions that represent the whole meaning of construct, right? So this can be a good example of composite construct, because actually when we don't have error term, when we know there is no any other missing items that can be added to this construct. So in this case, yes, we can go for composite construct, right? But if we have a concept that already exists, like satisfaction, and in the literature we find some items, but still there are possibility to add more items, right? But we could not find in the literature, right? So for this case, and this concept already exists, and we measure based on some item, different aspects of this concept, but still there are some missing items. So this is causal formative. So the concept of composite and causal formative, if we want to go through in detail, we need to provide different examples. My suggestion is to read our editorial to differentiate between composite, especially composite and formative. Because actually in the editorial, we discussed that this is not, actually sometimes we have something that exists in real world, but still the concept and the construct is composite, not causal formative, not formative. And it's not that in all situations we only can say for artifact construct. We can say composite for artifact construct, right? But my suggestion is to please read this editorial, and if you need more explanation, the beginning of next week, I can explain a bit more.
Thank you very much, Prof.
Okay.
Yeah, I just wrote in the chat box. I'm using the software and I have 2 or 3 papers online, but I was confused about how many items we can delete from one construct, providing if the value.
Let me explain measurement model and the structural model assessment, and we will discuss later.
Okay, thank you.
Okay. For assessment of measurement model, I tried to review this very quickly and go to software. For assessment of measurement model, okay, this is our paper that we published in 2018, assessment of use of partial squared structural equation modeling in hospitality research. But at the end of this paper, we actually provided a guideline for assessment of model, for assessment of measurement model and assessment of a structural model, and also some requirement for creating model, like for the research and, for example, minimum sample size in PLS and some other stuffs. I think this paper and the guideline at the end of this paper can be very useful for researchers in different disciplines and can be applied. This is another paper published by Hare and his colleagues in 2019, when to use and how to report the result of PLS-SEM. So this one is another very good paper, addition to many papers and literature that have published so far, addition to Hare book, that is very important book in PLS-SEM, and another books and articles that published. And so you can use these articles for understanding criteria for assessment of measurement model and structural model, and also reporting the result. For assessment of measurement model, depend on reflective, formative, and composite, and also for assessment of a structural model. For assessment of reflective measurement model, we need to check indicator reliability. We need to check internal consistency or construct reliability, convergent validity, and discriminant validity. Indicator reliability, we need to check based on loading, and loading should be higher than 0.7. But loading between 0.5 and 0.7 also is acceptable if other criteria for measurement model, for construct reliability and convergent validity, we meet threshold for these criteria. So in first place, we need to check loading, and no loading lower than 0.5 can be deleted for reflective construct. For internal consistency, we have the different criteria. The most common criteria are alpha, composite reliability, and ρA. ρA is a criterion that developed recently by Hensler and his colleagues, and at least we need to report 2 of these criteria for internal consistency and construct reliability. And these criteria should be higher than 0.7. Another criteria for convergent validity is average variance extracted. And this average variance extracted should be higher than 0.5 to be acceptable and to establish convergence validity. And for discriminant validity, these 3 criteria actually refer to convergence between items. But this discriminant validity refer to divergence between construct. So construct should be different, should be distinct when we apply, when we include different construct in a framework. And to assess distinction between these constructs, we need to establish discriminant validity. To establish discriminant validity, there are some criteria like Fornell-Larker. Fornell-Larker criterion is a traditional criterion to assess discriminant validity. And for Fornell-Larker criterion, we compare ADE with the square of correlation of construct with other construct or square root of ADE. And the square root of ADE should be higher than correlation of this construct with other construct. Cross-loading doesn't use this criterion for discriminant validity based on very no more literature suggests to use this criterion. And another criterion that was developed recently is heterotrait monotrait ratio. And this HTMT and Fornell-Larker is better to apply these two criteria together for assessment of discriminant validity. For HTMT, we need to calculate actually the HTMT ratio, and the HTMT ratio for each construct should be lower than 0.85 or 0.9 based on different literature. Actually, recently, Marco Zartset and his colleague published a paper that discuss in this paper that also HTMT ratio we can compare to 1, and based on actually confidence interval, if we check and see HTMT is significantly different from 1. So we can establish also discriminant validity. So no need to compare with 0.85 or 0.9 threshold, right? So if we want to apply this method, we need to calculate significant difference between HTMT value, HTMT ratio, and 1. And if it's significantly different from 1, means we can establish discriminant validity. So this is a few criteria for assessment of measurement model, reflective measurement model. Here I provided the formula and equation for a different criteria. This is a formula for discriminant validity, but no need to calculate this formula because actually this formula are these criteria are calculated by software. Just you can use it and interpret your result. For formative construct, actually we need to assess the relationship between formative construct and a reflective construct or one overall item. So this is one things that I refer to when I explain the formative and reflective. So when we develop our questionnaire and our construct is formative, we need to add some reflective items or one overall item to measure this concept. For example, if our concept is satisfaction and we measure satisfaction formatively, we need to add some reflective item to measure satisfaction or one overall item. For example, overall, are you satisfied and what's the level of your satisfaction with this product, with this hotel? And relationship between this formative construct and overall item or reflective construct should be higher than 0. The beta coefficient should be higher than 0.7. Means this formative construct, at least these items at least this item represents 50% of variance of satisfaction. So the higher, the better. So this is something that we need to check before going to create our model and assess measurement model and structural model. Before starting our analysis, we need to check this relationship for external validity or convergent validity of formative construct. Okay. For formative construct, we need to check multicollinearity VIF, and VIF should be lower than 5. And then we need to check outer weight, and the outer weight should be significant. If outer weight are not significant, we cannot easily delete formative item. For reflective item, yes, we can delete. If the loading is lower than 0.5, we can delete, because actually for reflective construct, each item should represent whole meaning of construct. But for formative item, formative construct is not easy to delete, because each item represents one aspect of construct. So if the weight is not significant, we need to check loading. And if loading is significant, we can still keep this item. Even the loading is not significant, it depends on your evaluation. You can keep this item and explain the weight and loading are not significant. Maybe for future research, and researcher can see this item in some research. But for your research, this item is not significant and actually is not meaningful to create score of your latent variable, and doesn't have significant contribution on your analysis, right? So for formative construct, is not easy to delete. For composite construct, one more things we need to add to VIF and the significance of weight is nomenological validity. And we need to check for composite construct, we need to check nomenological validity. Using, this is one place that goodness of fit is important. And for nomenological validity, we need to check goodness of fit before including composite and after including composite. And goodness of fit should not be worsened when we include composite construct. So this is nomenological validity for addition to VIF and weight for composite construct. So this is a criteria for assessment of measurement model of reflective and formative construct. For a structural model, actually we have many criteria. Only some of these criteria are common criteria that is long literature to support this criteria, like R square, coefficient of determination, R square, size and the significance of pad coefficient, effect size for each relationship and effect, and predictive relevance for Q square. For assessment of predictive validity of model. But recently, actually the models out of sample prediction using PLS predict was developed by some researcher, and still not, but recent literature are developing to actually suggest PLS predict and models out of sample prediction as part of necessary part of assessment of structural model. So for a structural model, we need to assess these criteria. Okay, let me go to software. The first session will be a bit longer because we have, I explained at the beginning, we have a lot of topic to cover. Okay. Okay, so actually to use a smart PLS, I'm not sure. Perhaps most of you are familiar with this software. And just very quickly, I review and give some point. This is a SmartPLS website. When you go to a SmartPLS website, you can download if you haven't used the SmartPLS so far, you can download you can use the free 30-day trial version of software. So you can download software based on characteristic of your computer and download and install in your computer and use your email address to get 1 month's free license and activate license. If you haven't used SmartPLS so far, so you can download and use this email address. If you are the user of software or already use this 30-day trial version, you have to purchase. But for a participant that register for this workshop, the developer provided the 2 months free license. So you can use that license to activate your SmartPLS. Also in the website, you can find a lot of good resources and information and courses, the online courses and face-to-face courses. Here you have find a lot of resources, book, some special issues, some review papers, some videos for SmartPLS, why choosing PLS and some features of SmartPLS, some features of PLS, not SmartPLS, some function of SmartPLS. So you can find a lot of good information. If you need any support from the team, they are very, very supportive, and you can join a forum, you can ask your question, and they will answer your question about using software. So the first step is to download, install, and activate your software to use SmartPLS. Okay, I assume most of you install and activate software before. Okay. Now we want to actually create a model in SmartPLS and see some basic steps for assessment of measurement model and structural model. Okay, when you activate your software, you can see this interface, right? Here, the first step to create your framework and your model in a SmartPLS is click on New Project. If you have some project that you are working, you can see your project here. How can activate SmartPLS? When you go to, when you install a SmartPLS in your computer, when you want to start, we'll ask you, we'll transfer to here, right? So here you can see some different types of licenses, right? One license is the student license, but this license and this version of software has some limitation. So if you want to just do some practice with the SmartPLS, we can use this version, and this version, the limitation of this license and version is 100 sample, and some features are not working on this version. So you can click on professional, and when you click on professional version, ask you to register here for 30-day full features tutorial version if you haven't registered before. you can click on this one and you send your email, and the developer will send you a license for 1 month. So you can use this license. If you have license, for example, 2 months license that we have in for this course and the developer provided, so you can copy and paste the license here and click on change license. So sorry, when you copy a license key here, you need to click on continue, and the software will be activated for you. So this is the way that you can install and activate and to activate for 2 months. Okay, don't have, yes, you have. You join Zoom, so you have access to Taylor's profile, the profile that Taylor's created for you. And I put the license in a PDF file in your profile. So you can download this license file and copy and paste the key in your software to activate. Okay, so the first step is to create a new project. So when you click on new project, for example, you put name, we put webinar PLSSEM. So click on OK. Here you can see 2 options. One is your actually pad model. So you will create your pad model here with this icon. This icon is similar to pad model. And here you have another option to import your data. If you click on this option, you will transfer to here. You can choose your folder, actually the folder that you have your data set. The data set suitable for SmartPLS is the type of data set should be CSV data set, comma delimited data file. If you have SPSS data file or Excel data file, you can transfer, you can convert your SPSS data file or Excel data file to CSV. Okay, let me show you. Okay, just click. I already converted to CSV, so this is acceptable for SmartPLS. Later, I will show you how, if we have SPSS file, how we can transfer, or Excel file, how we can change to CSV. Click on this one and open. So data set for webinar. Okay, I choose this name and click. So here you can see your data file. And when this icon is green, means your file is usable, is functioning for your framework and for your analysis. If this icon is red, it means there are some errors to transfer your data file, or some errors in your file. So you need to go back to your file and see what are these errors and solve these issues, and again import your data. So now we have data file here, and we have this option to create our pad model. But before going to this, let me explain. For example, if you have this data set, can you see this SPSS file?
No, Prof.
No. Okay, let's share again. What about now?
Yeah, now it's okay.
Yes.
So if you have a SPSS file and you want to transfer SPSS file to use for a SmartPLS, so you can save as this file, okay? Save as this file as this file originally is SAV file, right? But you need to save as comma delimited file, comma delimited file, or CSV file. So if you click on this CSV, so you can create the CSV file for webinar, and you can choose the folder that you want to save and click on save. So now you have, in this folder, you have, but you cannot see my folder. Now you have the CSV file. Also, if you have Excel file, you can transfer Excel file using Excel to CSV file, comma delimited file. So based on the file that you have, you need to create a CSV file, and you can use and import this CSV file in your software. So now we imported this CSV file to our software, right? Now you can see, right? You can see my SmartPLS screen.
Yes, sir.
Okay. So after importing your CSV file to SmartPLS, you can go to this part, this option, to create your pad model, to create your framework. When you make sure that your data set is green and is okay, so, but here you can see very good information about your data set. There are different variables that you have, different observed items that you have. You can see missing value here. If you have any missing value here means empty cell, right? But here, if you define missing value, for example, if in your file you define 99 as a missing value, so here you can change missing value and define for software what the missing value means in your data set. If you don't have any specific missing value, this only the software will realize empty cell as a missing value. So here you can see mean, you can see median, minimum, maximum, and standard deviation, cortices, and skewness. So you can see some actually descriptive analysis for items here in your data file. Okay, so when you transfer data file to your software, when you click on your this option to create your path model, here in this window, in this interface, you can see a white window, nothing here, right? So here you can create your framework. But here in this box, actually you have indicators. You have different indicators that actually include in your data set. So here you can create your framework. I already this is another file that I uploaded in your platform, in platform created by Taylor. Here there are some exercises that we will work in during this course. The first one is for assessment of measurement model and structural model. And in this actually model, we have 4 exogenous variable and 3 endogenous variable. Community attachment, economic gain, environmental attitude, and cultural attitude are exogenous variable in our framework, and economic perceived impact, social perceived impact by resident, and environmental perceived impact are endogenous construct. So this is the framework that we want to create in SmartPLS, right? Okay, so to create framework, the first thing is to actually create latent variable. In this menu bar, you can see different options that these options help you to create model and analyze model. The first thing is latent variable option here. You need to click on this latent variable option and click on this white window, click on your interface. How many latent variable you have? We have 7 latent variable. So when you click on this white window, you will create this latent variable. When you actually create the number of latent variable that you need to click on select to inactivate this option. So now we have 4 exogenous variable and 3 endogenous variable. The first one, based on our framework, is you can right click on each latent variable and change the name. So we right click on the first one and change to community attachment. So this is community attachment construct. Second one is economic gain. Third one is environmental attitude. And the last one is, exogenous variable is cultural attitude. So we changed the name of these 4 independent variable and 3 endogenous construct. We changed the name of these 3. First one is perceived economic impact. Second one is perceived social impact. And the last one is perceived environmental impact. Right? So we have now we have these 7 latent variables, but these variables don't have any items. So we didn't allocate items for, we didn't assign items for each latent variable. Items, we have list of items we have here, list of indicators we have here. Okay, community attachment. There are 4 items to measure community attachment. So we need to click on these 4 items. We can click on first one and the hold shift and click on the last one. So we can drag and drop on latent variable. Drag and drop on latent variable. So we will transfer this 4 item to community attachment. Second one is environmental attitude. So again, we have this tree and transfer this tree to environmental attitude, cultural attitude, drag and drop, and economic gain. Drag and drop. So we assign items for exogenous construct to these 4 exogenous constructs. For perceived economic impact, perceived social impact, and perceived environmental impact, also we need to transfer items. So for economic impact, we have 4 items. So we transfer these 4 items here. 3 items for social. And for environmental, we have also 3 items. Okay. Now we assign observed items or indicators to each construct, right? So, but if we want to change the alignment of each items of each construct, we need to right click on construct and align the indicator to, we can change indicator to top, left, bottom, and right. So if we right click, we can change, we can align to right, bottom, left, and top. So here we align to right. And for this one, align to right, and this one also change to right. Okay, but still you can see the construct are red. Red means still we need to do something to be able to perform analysis. In PLS, we need a relationship between items. We need nomenological relationship between items to be able to perform analysis. So for this one, we need to click on connect. And to connect item, we need to click on first beginning and the end of construct. Beginning, click on beginning and click on end. Click on beginning and so we can see now is blue. Blue means we have relationship between all constructs, but still we need to create 2 more connection, 2 more arrows based on our framework and model. When we complete connection between arrows, just click on select. So now we have our framework, we have our model, including 4 endogenous construct, exogenous construct, and 3 endogenous construct with their associated items, indicators, right? So now we After creating model, we need to perform analysis to see the criteria for assessment of measurement model and structural. To perform analysis, to perform basic analysis, in this menu bar, we need to click on calculate. And in calculate, we have many different options. The first option is PLS algorithm. So this option is performing PLS based on basic PLS algorithm, right? So we click on this one. You will transfer to here. Just click on start calculation. Start calculation. And when you click on start calculation, here you can see different results. And you need this result for assessment of measurement model and structural model. Actually, our construct all are reflective, right? So we need to check loading, we need to check reliability, construct reliability, we need to check convergent validity and discriminant validity. So first one is loading. Click on here, you can see different options and the result of analysis you can find in these different options. When you click on outer loading, here you can see loading of each item on its construct, right? So here, the loading higher than 0.7 are green, but lower than 0.7 are red, but it doesn't mean that you need to delete this one. If the loading is higher than 0.5, you need to look at the thresholds of convergent validity criteria and construct reliability criteria, CR, ROE, Composite alpha, and AVE. So here, higher than 0.5, all for community, for cultural attitude higher than 0.7, acceptable. Environmental attitude 0.7, acceptable. Economic gain, acceptable. For perceived economic impact, only one is 0.649. So we need to look at reliability and validity. The other criteria, CR and ADE. For environmental impact, we have three items are higher than 0.7. And for social higher than 0.7. So loading are almost acceptable, except these items we need to look at convergent validity criteria and construct reliability, CR and AE. So this is for first step. For second step, to check the construct reliability and convergent validity, we need to click on this option. Here, for construct reliability and validity, you can see the result of current batches alpha, ROE, composite reliability, and AVE. Current batches alpha and ROE and composite reliability should be higher than 0.7. So for all construct are green, means all are higher than 0.7 and acceptable. And the AVE should be higher than 0.5. And here you can see 0.58, 0.69, 65, 7, 0.558, 669, and 633. So construct reliability and AVE are acceptable for all construct, all reflective construct. So we can establish reliability and convergent validity. Now we need to check discriminant validity. For discriminant validity, we need to go to another option. If we click on discriminant validity, there are different options here. Fornell-Larker criterion, cross-loading, heterotrait, monotrait ratio. For Fornell-Larker criterion, here you can see a table And in this table, for CA and CA, this is the square root of AVE. So here you can see square root of AVE of CA. And compared to correlation of CA, community attachment with other. So here is this square root of AVE is 0.763. And correlation of CA with CAT is 0.37, 0.40, 0.133. And this one is higher than all the correlation with all constructs. You need to check these values for each construct with the correlation of this construct with others. And the square root of AV should be higher than correlation of each construct for other construct to establish discriminant validity based on Fowler and Larker criteria. But for heterotrait, monotrait, here you can see all are green. Green means the HT-MT ratio is lower than 0.85. But if high is higher than 0.85, but still lower than 0.9 is acceptable. So you can see the result of Fowler and Larker criterion and heterotrait, monotrait here for assessment of discriminant validity. So for this framework, we can establish discriminant validity based on two main and the most conservative criteria: heterotrait, monotrait ratio and Fowler and Larker criteria. So this is for assessment of discriminant validity and assessment of measurement model for our framework. For a structural model, only I mentioned two main criteria, and next week we will go through a bit more for assessment of a structural model and see different criteria. For assessment of a structural model, we need to check R square. So R square is here. R square and R square adjusted you can find here for three endogenous constructs. So the value of R square is 0.3, 0.3, 0.21, 0.21, 0.20, and 0.209. The value of R square and threshold for R square is depend on your area. If actually you are working in marketing in some area that you include all success factors, for example, for endogenous construct, so the R square should be high. Chin suggests the R square 0.67 and higher, consider high R square. And the R square lower than 0.19 is not acceptable. But if we actually include all success factors and all factors that create variance, explained variance of PV. But in behavioral science, that only we include some variables, doesn't matter. And in behavioral science, actually, because we don't include all variables, we don't include all factors that influence on DV, the value of 0.2 based on Cohen, the value of 0.2 also can be considered high, can be considered higher than 0.26, can be considered high in behavioral science. Or some literature say that higher than 0.2 can be considered a high value for R square. So it depends on your area and your and previous studies. Another things we need to interpret for a structural model is path coefficient. So here you can see path coefficient. But to interpret path coefficient, we need to see the significance of path coefficient. And next week, I will discuss how we can get significance of path coefficient and interpret path coefficient and also effect size for assessment of a structure. Okay, So I think it's no, already 1.5 hours. So it's enough for today. I'm here if you have any question for this session. And we will continue next session on assessment of a structural model, and if there are something about assessment of measurement model, and then we will go for higher order construct.
Prof, may I ask a couple of questions?
Yes.
First question, do we have in PLS CFA or we don't have, and why?
CFA is equal to assessment of measurement model. CFA is actually assessing reliability and validity. So we evaluate reliability and validity of construct by some criteria. So it's equivalent with the CFA. But in covariance space SEM, addition to these criteria for assessment of measurement model, we also apply goodness of fit to complete CFA. This is because of the reason of application of covariance space SEM. I explained in the introduction that covariance space SEM, the focus of covariance space SEM is on minimizing the difference between covariance matrix from data and from model. So this is the objective. This is the mission of covariance space SEM. So we need to report goodness of fit. But the mission and the objective of PLS-SEM is different. Here we try to maximize explained variance of endogenous construct, right? So goodness of fit is meaningless. Assessment of measurement model exactly is CFA, equivalent of CFA on CBSEM.
Okay, Prof, last question about the Likert scale. So can we use 2 Likert scale, for example, yes or no, or we must have 5 Likert scale
No, you can use different Likert scale because PLS, before starting analysis, standardize all your variable. So it doesn't matter which type of Likert scale that you have used. You can use 1 to 5 for one variable, 1 to 7 for another variable, 1 to 11 for another variable. So it's possible.
Dichotomous scale also. Dichotomous, yes or no?
Dichotomous variable is not possible to include as a endogenous construct. Possible to include the when you apply PLS-SEM, but you can use as exogenous variable.
May we know the reason?
Because actually when you apply, when you use the dichotomous variable as endogenous variable, you need to apply non-linear approach and S-curve approach. Because dichotomous variable in DD create S-curve relationship, not linear relationship. So, but in PLS, we apply linear relationship. So it's not possible to have dichotomous in as a DD. But there are some ways to actually convert the results and use the results to apply for logistic regression. So we can actually combine result of PLS and logistic regression for when we have dichotomous DD.
Thank you very much.
But in other software like VAR PLS, there are some features, S-curve features that perhaps we can use these S-curve features for dichotomous DD, but it's not possible in basic PLS and SmartPLS.
Thank you, Prof.
I have one question about the nomological validity of formative construct to check or to validate the measurement model. So just would you please repeat a little bit, because you're telling that it requires goodness of fit and it can be done before adding or after adding. So I didn't get that point.
Okay, When we have composite construct, nomonological validity is one of the criterion to assess the measurement model of composite construct. When we have composite construct, before establishing composite construct, we need to check the goodness of fit or fit indices in PLS. So we run model without composite construct. Right?
It means like without composite means reflectively we will run the model and we'll check the.
No, we don't include. We don't include composite construct.
Oh, okay. Like if I have a model of 3 variables, so without including that composite variable, I should check the goodness of fit.
If you have composite construct, higher order composite construct, for example, you have second order that in second level is composite, but in first level is reflective, you can add the first order dimensions.
Okay.
Then you have first order composite, we don't include composite construct.
Okay, I got it. So with that, I need to check for the goodness of fit, and that should be that should have meet the minimum criteria, for example, 80% or some 90%. Is it like that?
Fit indices before including and after including should not be worsened, right? At least should be same.
Okay, I got it. Yeah.
Okay.
Yeah.
Thank you so much, dear Prof.
Do we need to report HTMT ratio for a second order reflective formative construct?
For HTMT, we don't have HTMT for formative construct, right? So HTMT is only reflective construct. So if you have second order reflective formative, means you can report HTMT for first orders. I will explain in detail, because when we have the higher order, we need to assess model by first order and then create second order. So in first stage, you can report HTMT. But when you create formative second order, you cannot report HTMT for this formative construct. But there are some way, but not actually the simple and clear way. You can change the mode to mode A and still you can get HTMT. But actually this is not suitable based on the concept of HTMT. So for formative construct, actually HTMT is not applicable.
Thank you, Prof.
Prof, may I ask a question?
Yes.
Sir, I'm Shafkat and I'm from UPM, and I'm from linguistic background. So this is my first time I'm participating in a workshop on SmartPLS. So it is really wonderful experience for me. And I'm watching this with my wife also. She's going to ask you next question. So Prof, my question is related to goodness of model. So is it the similar idea that SPSS gives the goodness of model fit like in multiple linear regression? Is it the same concept of goodness of fit model?
What do you mean? If you for goodness of fit based on traditional definition, you mean you consider R square and this value, this criteria as a goodness of fit? Okay, yeah, create R square so you can interpret based on R square. If goodness of fit, you mean something similar to covariance-based SEM, because we have some criteria in covariance-based SEM to assess goodness of fit. I explained that the purpose of PLS-SEM is totally different with the covariance-based SEM. And goodness of fit is to compare covariance matrix between data and the model. So we don't have this comparison in PLS-SEM, unless in some situation like assessment of composite, or when we have to compare two different data sets. So we apply goodness of fit. But in basic analysis and regular analysis, it's not very meaningful, similar to covariance-based SEM. right? So apply in first place goodness of fit for assessment using PLS.
Right, Prof. So you mean to say that it is just like the goodness of it shows how fit is the model, or how relationship or how it establishes the relationship.
How data
yes.
is fitted to the model.
How data
so
is fit or accurate. Yeah, how data is fit or accurate towards the model.
Yes, yes.
Right, sir. Thank you very much, sir. Thank you very much.
Can I ask question? Yasir Rasool here, sir.
Yes.
Okay, respect sir, Prof, I'm working on a paper where I have taken memorable tourism experience as a second order construct, and its first order dimensions are hospitality, infrastructure, special events.
If your question, sorry, I drop you. If your question is about the higher order construct, and next week we will focus on higher order construct. So you will ask your question about higher order next week.
Okay. Okay.
I will explain in detail what's the meaning of higher order in some situation, in what situation we can apply higher order, and how we can evaluate.
I just wanted to know the operationalization, your opinion about whether it's, I'm confused about it, whether it's reflective, formative.
I'm not sure. It depends on your literature and depend on the item that you apply.
Okay, we can discuss in next week. Thank you.
Yes.
Thank you very much.
Yes, no problem. One more question.
Prof Mustafa, can I have a question?
Yes.
Okay, I'm Samuel, so I've studied at USM, so I always following Facebook. So I would just like one question is all about reflective and formative model. Just now at the beginning you mentioned like we can refer previous study, right? In like whether this model is reflective in nature or is a formative. But what if we cannot find any literature? Maybe this valuable is new, right? And how we make a judgment whether this concept should be reflective or formative? Do you have any idea?
Actually, when you are conducting a quantitative research for developing your questionnaire and actually measurement item for your construct, you need some support from literature. If you don't have any support from the literature, it means you develop your item based on some prior study, some, for example, qualitative phase.
Okay.
So it's not possible to develop item based on your idea, your opinion, right? So you need to find some sort of support for development of your items. Actually, this is something that I mentioned about measurement story. So you need to support your items based on literature. If you don't have, you need to run a qualitative phase to develop your item.
Okay, I got it. Thank you, bro.
Okay, thank you very much for attending this session.
Excuse me, sir, I have a question. Sir, my question is, do we need assumption of normality, just like we are using in SPSS? Is it compulsory for SmartPLS measurement?
Sorry, assumption for what?
Assumption of normality as we practice in SPSS. Yes.
Actually, PLSSEM is a non-parametric approach, and it's good to assess normality, especially multivariate normality for our construct in PLS. But it's not a strict requirement, because in PLS we apply resampling method and bootstrapping method, and by application of resampling method and bootstrapping, actually we perform a non-parametric analysis with non-normal data.
Right, sir. Right. Thank you, sir.
Thank you very much. And I will see all of you next week on Thursday, and we will discuss higher order construct. We will continue for assessment of a structural model, and we'll discuss higher order construct. Okay, thank you. Thank you for joining me.